Welcome. This is Algebra 2. We're looking at 8.3b today, and the topic is inverse functions. Now, the one way to think of how to find an inverse function is that the x and y variables have to be switched around in order to find the inverse of a function. This is essentially what will make a machine go backwards. And if you would, put your phone, in your bag. Actually, class has started. So those of you who are on your phones, go ahead and just whoever you're texting, maybe just tell them that you're in school now, and we are ready to roll. So, thank you. So, we are going to, there's actually 4 steps in this process. Sometimes the first step is done, but let's make step 1 is replace the f of x symbol with the y symbol. And then step 2 is to switch x and y. Think of it as x and y are trading places. Then the third step is to solve for y. Then the fourth step is to label as, basically it's replace. Just cross out that. A better phrase is replace y with, you can use the symbol f inverse of x. So the inverse concept is one you're actually already pretty familiar with, because if you want to think of a process where, suppose we have a function where we multiply by 3 and add 1, if that's your function f of x, the kind of cool thing is that you can do some of these in your head. Some of these are easy enough you can do in your head by simply imagining a process going in reverse. We've referred to these as movies in the past. Now it's actually the topic. Watching movies backwards is the whole lesson today. If you were to watch the multiply by 3, add 1 movie in reverse, can someone describe for me what it would look like? What's the inverse or the reverse process of multiply by 3, add 1? Raise your hand if you're reasonably sure you know. All right. Jack, do you have it?
No, not there yet.
All right. Well, you don't have to be there, because it's right here. How would you reverse the process of multiply by 3, add 1?
Divide that through, subtract.
Well, that's the inverse operations, but you have to go in reverse order. So if you're watching a movie that starts with multiplication by 3, and the order of operation says you have to multiply before you add. So if you multiply by 3, and then at the end of the movie they add 1, if you were to watch that movie backwards, what's the first thing you would see?
Subtract 1 and then divide by 3.
Yeah, it's subtract 1, divide by 3. So some of these you can just do in your head, and we've been doing it all year long. We've been taking a process, a 2-step process, and watching it in reverse. Now, you can distribute the 3 to get 1/3 x minus 1/3. This is the inverse function. So this is basically coming up with a rule that will make the f machine work in reverse. By the way, it's potentially confusing to see this symbol f inverse of x, because some people make the mistake of thinking that it means 1 over f of x, because we just came out of a unit where we had negative exponents, and didn't we do that every day for like weeks, where we would take a negative exponent and, Owen, do you have a question on that? No, okay. So check this out. This is a very common mistake students make. They think that f inverse x means 1 over f of x. It's not true. When I was in high school, and I did go to high school, I didn't just like walk in off the street today. I actually graduated from high school. Even went to college. I'm trying to think of which college was it that I went to.
Wheaton College.
Oh, that's right. It was Wheaton College.
Wow.
That's crazy.
I don't know how word got out on that. Oh, question, Bethany.
Can I go to the bathroom?
What we do is it's after the lecture. We do, so it's like, it's our new thing. And that's where Mr. McDonald and I are together. So just hold on a second. I was actually in the middle of telling a story, and here's the story. The story is this. When you have negative exponents on a polynomial, then yes, you can write that as 1 over x. However, when I was in high school, my pre-calculus teacher Mr. Schneider got angry only twice. I saw him get angry only twice. One was when someone phoned in a bomb threat to the school, and it was right during math class, and everyone had to leave the building, and boy was my math teacher angry. The only other time I saw him get angry was when he graded the tests on inverse functions. And some students had gone through we had a whole unit on inverse functions. And there were students who thought that f inverse of x meant just take 1 over f of x. They thought the answer to this problem, because of their confusion, I mean, think about it, they went through the whole unit thinking that f inverse of x meant that if you want to find the inverse of this function, f inverse of x, you just take 1 over 3x plus 1. Well, 1 over 3x plus 1 is not the same thing as 1/3 x minus 1/3. And that's the only other time he got angry, is when people were confused as to what that -1 means in inverse functions. So now, I'm not saying that if you make that mistake that I'll be angry. I mean, if you phone in a bomb threat or something, yeah, that will probably make me angry, but I'll probably be able to get past it if you make the mistake of thinking that f inverse of x is 1 over f of x. It's simply not. Okay, so how do we find an inverse function? Well, here we go. There's 4 steps. Step 1 is to replace the f of x symbol with y. So step 1, you've got y equals x squared plus 1. And by the way, I noticed there was a mistake in this example. I spotted it before the lesson, and I went to Mr. McDonald and I said, you know, there is a mistake in example 1. He said, you're right, so we have to fix it. The mistake that we're correcting today, that's in the student notes, is that there's a domain restriction on this. This x squared plus 1 function has to have a restricted domain of x is greater than or equal to 0. And throughout today's lesson, actually, and on the solutions, I'm putting the original function in red and the inverse function in blue, because we're going to look at how they contrast on a graph. We're going to see the beauty of the original function and its inverse function sketched on the same pair of axes. So, here we go. Step 1, just replace f of x with y, and the domain is positive numbers and 0 only. The second step is where x and y trade places. This is where red turns to blue. The original function is red. The inverse function is found by letting every y turn into an x and every x turn into a y. So that's where red changes to blue. X and y trade places, if you will. And in fact, there was, here the verb is switch. You can think trade, X and Y trade places. There was a movie entitled Trading Places, starring Dan Aykroyd and Eddie Murphy. And it was about 2 men who traded places in life. I'm not going to tell you how it ends. What kind of person do you think I am? But the point is that you can think of the characters in that movie were played by, by Eddie Murphy and Dan Aykroyd. So it's like, you can think of this as Eddie and Dan. This is Eddie, that's Dan. But when you get the inverse function, it becomes Dan and Eddie. So Dan and Eddie trade places. All right, next. The third step in this process is to solve for y. So as we solve for y, and by the way, there's codes for this whole process here. Go ahead and write this down as the original equation. And the trading places code is a double arrow on x and y. That means Dan and Eddie are trading places. X and y just trade places. Now to solve for y, we're going to S1. Check this out. When we subtract 1 from both sides, we get x minus 1 equals y squared. And then, who recalls what the code is to solve for y when you have y squared equals x minus 1? Gerald, do you know?
Would it be R?
Now, if it were a square root, then I would raise both sides. If it were square root of y, then it would be r, like r cubed. But since it's y squared, what's the code for solving for y? Raise your hand if you think you know. Andrew.
DSR.
DSR stands for the definition of square roots, because we essentially need to take the square root of both sides. So go ahead and write DSR, because that's actually, some of you were a little bit weak on that. And so this is where we solve for y to get plus or minus. DSR always has a plus or minus, the square root of x minus 1. However, the negative sign has to be rejected. Part of that's because of the fact that y started out to be greater than or equal to 1. When Dan and Eddie trade places, then the domain and the range trade places. So we know that in our inverse function, it's going to be x is greater than or equal to 1 and y is greater than or equal to 0. Not only do x and y trade places, but the entire domain and the entire range trade places. So whatever the range of the original function was becomes the domain of the new one, and whatever the domain of the original function was becomes the range here. Now, here's a contradiction. How can y be greater than or equal to 0 and y be a negative number? Because of this switching of the domain and the range, you have to reject the negative square root and just write y equals x minus 1. That's because of this domain restriction. So y equals x minus 1, and what we did was we reject the negative. We had to reject the negative because of the domain restriction. And now finally step 4. In step 4, I replace y with the symbol f inverse of x. It looks like f to the negative 1 of x, but that's what made my math teacher so angry back in the day. No, it's not f to the negative 1 power. It means something else. It doesn't mean reciprocal. It means inverse. It means watch the movie backwards, Jack. That means watch the movie backwards. Instead of square the input and add 1, we're going to subtract 1 and then take the square root. Which if you think about in terms of watching movies backwards, you could have gotten this just by watching this movie backwards. Instead of squaring the number, adding 1, let's subtract 1 and then take the square root. Yeah.
Because we can't see.
Well, yeah, anyone, because of the placement of the camera, if anyone needs to move to a different seat, feel free to do that. All right, so the picture, and you'll be drawing pictures of the original function and its inverse today. I would like you to draw a graph over here on the side. Let's just do a quick sketch of the original function. I'm going to do it in red. You know how x squared is a parabola? When you shift it up 1, it goes up, but we're only doing half of a parabola. Because of this domain restriction, because I said the only golf balls that are allowed are those greater than or equal to 0, the original function, x squared plus 1, domain restriction is the right half. Notice how our answer is the square root of x minus 1. That's the square root of x parent shifted right 1. So, here's the square root of x graph shifted right 1, and here's the Dan-Eddy line. The Dan-Eddy line is a playful, informal way to refer to the line y equals x. Y equals x is the line where y and x are equal to each other. It's where Dan and Eddie are equal to each other. So, Gerald, question? Yeah, sir. Here you go. Yeah. So, class, here's how I spotted the mistake in the lesson. Whenever you plot the red graph and the blue graph, the function f and its inverse function f inverse, when you put them both on the same graph, there should be beauty in the symmetry. When you take red and blue with the line y equals x, together it should all be symmetric. Now, the way the notes originally were written in the lesson plan for Algebra 2, when I walked into the building this morning, the notes were written like this. There was no domain restriction. And so you had the parabola y equals x squared plus 1, and the answer, according to the notes, was this. That's not symmetric. This is ugly. So we have beautiful and ugly. You can tell that there's a lack of symmetry here. When you reflect the red graph over the line y equals x, you get a plus or minus. You get a positive square root and a negative square root as indicated by DSR. But because we wanted the answer to this one to be just the positive square root, that meant that there had to be a domain restriction on the original function. We had to say, no, we're not gonna take all x's, we're only gonna take the golf balls that are greater than or equal to 0. Otherwise, the solution will be ugly. This has the beauty of symmetry. And that's what you can always do to check to see if your answer is correct. So let's do another one together. Let's do a brand new example. Example 2, the original function in red. Step 1, replace f of x with y. So tell me, please, let's go to Jonathan. What's step 1? When I take the original function and replace the f of x with y, what do we get?
Y equals 2x minus 4.
Yeah, and let's just, document that as the original equation. Okay, so now, Thomas Kelch, here's your code. Your code is the double arrow. When you respond to this code, what is the line of algebra?
X equals 2y minus 4.
X equals 2y minus 4 is correct. Yeah, that's where x and y trade places. So class, go ahead and solve that for y. Solve the equation for y. And then replace the y with f inverse of x. So for your final step, I hope you came up with f inverse of x, because we have to replace the y with f inverse, equals 1/2 x plus 2. So later in the lesson, they're going to ask us to come back to example 2, sketch the original function in red, then the inverse function in blue, and you're going to experience the beauty of symmetry between f and f inverse. Any questions on example 2? All right, let's keep going then. In example 3, we got a chance to lean on the homework that was due today. So, what's line 1 of this inverse process going to be, Gerald?
Y equals 3x.
Yep, that's replacing f of x with y. Next, we do the trade places routine. Daniel, what happens when Dan and Eddie trade places?
X equals 3y.
That's awesome. X equals 3. Did you say 3y?
Yeah.
It's 3 to the y. 3y is something else.
Oh, 3 plus y?
No, say 3 to the y.
Oh, to the y.
Yeah, 3 plus y, 3y, and 3 to the y are all different things. You have to say 3 to the y power. Now, to solve for y, we get to use log form. And I'm giving you, so what are the new codes today? We've got one of the new codes is x and y trade places. That's x double arrow y. The next new code is LF. That's log form. Let's, just like we did in the homework that was due today, let's take this equation that's in exponential form and let's write it in logarithmic form. How do we do that? Well, based on the work that we did for the homework due today, we said it's going to be log base something of something equals something. So the log is going to always be equal to which part of the equation? In one word, what is a log? Class?
Piece of wood.
In mathematical terms, what is a log? It's an exponent. So the log should equal, what should I put over here, Owen? Which is what?
Y.
It's y. So we know, and the base is going to be the same. So it's going to be log base 3 of something equals y. The only other thing to put in there it is. There's a log form, which means we just solved for y. And therefore, all that remains for step 4, and that is to replace y with the symbol f inverse, not f to the negative 1. Is there anyone who's willing to honestly admit that when you see this symbol, the words that flow through your mind are f to the negative 1? You have to not let those words flow through your mind anymore. That's what made Mr. Schneider so upset. Students thought that was an exponent of negative 1. It's not! It means inverse. It doesn't mean reciprocal. It means inverse. It means watch the movie backwards. So there's your final answer. Any questions on number 3? Okay. Now, let's go on. Number 4. Step 1, f of x is y. So we got y equals 5 to the x minus 2 plus 1. Oh, question. It sounds like there's a question.
This is about the previous problem.
About this one?
No.
Oh, the one up here? Yeah. So what's your question?
I was just wondering like why you had like
1/2 x plus 2?
Yeah.
Well, I divided both sides by 2. So,
Well, why is it 1/2 in front of x?
well, check this out. The codes were A4 and D2. When you have to divide all 3 terms by 2. 2y divided by 2 is y. X divided by 2 is x divided by 2, or 1/2 x. And 4 divided by 2 is 2. All 3 terms have to be divided by 2. Okay?
Okay.
All right. So now, in fact, let's go to Anna on this one. What's the trade places line going to be on this one?
X equals 5 to the y minus 2.
Keep going.
Plus 1.
Plus 1. That's correct. Okay, so now you have to solve for y, the first step of which is S1. So let's subtract 1 from both sides of the equation. And I'm going to flip it also to make it 5 to the y minus 2. So 5 to the y minus 2 equals x minus 1. That's the net effect of subtracting 1 from both sides. Now we're going to use that LF code. Let's change this equation from exponential form to log form, just like on the homework. So it's going to be log base something of something equals the exponent, which is y minus 2. See if you can fill in the base and the input for log form. Whenever an equation is in exponential form and the thing you're solving for is in the exponent, then use log form to solve for that variable. All right, so let's go to Sophia. Log base what? Okay, well, you know what? That then brings up the question of how did you do the homework that was due today? Because in the homework that was due today, they asked you to do the same thing. They asked you to take an expression that's in exponential form and put it in log form. So, Sophia, eyes up here. Look at number 10 from the homework that was due today. Do you see that the base of the log expression is the same as the base of the exponential expression? So the base is always going to be the same. The exponent is always equal. A log is an exponent, so that's why we knew to say log equals 2. So using the examples from the homework that was due today, revisit this, Sophia, and tell me, what would the base of the exponential expression be? It's base 5. And the only other thing we have to fit into log form is the x minus 1. So the x minus 1 has got to go. There's only 3 slots into which you can place things. You have to place the base, the exponent, and whatever it's equal. Those have to go into the 3 slots. So now we finish it up using the A2 command, and this completes step 3. Step 3 ends with y equals the log base 5 of the quantity x minus 1 plus 2. All that remains is step 4, which is replacing y with not f to the negative 1 of x. Heavens, it's not f to the negative 1 of x, it's f, what's the word? Inverse. It's f inverse of x is log base 5 of the quantity x minus 1 plus 2. And question, yes?
Can you please just down, like right at the end?
Yeah.
To the right?
Yeah, let me zoom in on it. No, it's fine. Okay, so let's pause here. Are there any concept questions on how we were able to change, let's say, the exponential expression to log form, or get the final answer? Yes?
Can I just ask, for example, 1, like why did you reject? You said like you reject negative. It was like DSR plus or minus.
Uh-huh. Okay, so the question is, on the first one, why did I reject the negative? Because DSR gave us a plus or minus. I'll tell you this much. If we had not restricted the domain up front, and Sophia, do you see behind you those markers? Would you grab one of those markers and whip it in my general direction? I'll protect the camera, don't worry, just whip it. Oh, and then, so what we have here is, can anyone toss me, like, whip an eraser in my general direction? Okay, so what I'm doing here is, since we're on camera here, we're gonna do it right up here on the screen. So,
No throwing pencils.
here's the plan. What if I had not given you the domain restriction up front, Gerald? This is, by the way, really appreciate this question. We're starting in red. So what if there was no domain restriction? Then y equals x squared plus 1, it would have been, the original function f would have been this. And if we would have kept the plus or minus, we would have had positive square root of x minus 1 and negative square root of x minus 1. We would have had both. We could have kept the plus and the minus, and notice the beauty of the symmetry where you can see how the red reflects over onto the blue when you fold it over the line y equals x. It's because we had a full parabola at the beginning that we need both positive and negative square roots at the end. But we decided to say, what if we take only half of a parabola at the beginning? And this is why we have to sketch the graphs of these things. Otherwise, you won't really know why we're rejecting the negative. Because we only took the right half of the parabola, we need only the positive square root in order to maintain the beauty of symmetry that always is displayed when you show f and f inverse on the same pair of axes, okay? So, it's because we're avoiding ugliness. And also, there's a more technical way to explain it in terms of the domain and the range of the original. In fact, so, because some people are a little uncomfortable talking about beauty and ugliness. I mean, we're in math class after all. So you say, well, I want some sort of explanation that talks about domain and range. It's like the domain of the original is 0 to infinity, and the range of the original is 1 to infinity. That means that on the inverse function, the domain and range have to trade places. So on the inverse function, the domain has to be 1 to infinity, which it is on both. And the range has to be 0 to infinity. And so that's the mathematical answer to your question. Because the range has to be non-negative, we have to reject the negative square root. Okay? So, thanks for caring.
I care.
Thank you. Yeah, I can tell.
For answer.
Okay, so the answer to Gerald's question is actually in the lesson.
Oh.
So let's go to page 2. The domain and the range have to be switched, not just x and y. Yeah, go ahead.
Can I please go to bathroom?
Yeah, I mean, if it's an emergency, go ahead. One emergency every 2 years. So, all right, so. Oh, I just telling jokes. It's just a joke, but not an emergency. See, don't retell the jokes. People have to listen if they want to hear the joke. You can't go saying, oh, I'm only going to listen when it's a joke. Okay, so now, class, let's take a look at these inputs. Golf ball 0 goes up 1. Golf ball 2 goes up to 2 squared plus 1 is 5. And golf ball 3 squared plus 1 is 9. So, now the question is, what if I want to watch the movie backwards? The movie going forwards is 0 goes to 1, 2 goes to 5, 3 goes to 9. I mean 10, it's not 9, it's 10, because 3 squared plus 1 is 10. What if we start at the end of the movie? This basically is telling us that if you start at the end of the movie and you watch the movie backwards, you'll get back to 0. 5 will turn into a 2, and 10 will turn into a 3. How do we know? Because that's what the inverse function does. It takes the square root of the output minus 1, which gets us back to the input. So if the output was 5, just take the square root of 5 minus 1. That's the whole purpose of this inverse function. It's to reverse the process of f. This is f. This is f inverse. They undo each other. So to prove that this is true, we're gonna take 10 minus 1, which is 9, take the square root. So the inverse function, and by the way, that y to the negative 1 notation, I've never seen that before. I don't even think it's in the book. So you're gonna, because, good grief, when you see y to the negative 1, your mind is gonna go 1 over y. So that's a terribly confusing notation. Avoid it. Cross it out when you see it. Replace it with f inverse. Otherwise, the possibility of being confused is exponential. It rises exponentially. Okay, so here we go. And now, for the beauty aspect of these graphs are in the lesson. They are beautifully symmetric with respect to the line y equals x. So, basically here in problem 2, they just want you to enjoy the beauty. Let's take the graph of y equals x squared plus 1. And this time, Gerald, let's do it without the domain restriction. Let's just say, okay, here's x squared plus 1. And if you don't have the domain restriction, then by the time DSR comes along, then you don't have to reject the negative. So you can do the positive square root and the negative square root. So if you have y equals x squared plus 1 without a domain restriction, then notice how when you sketch the Dan-Eddy line, which is our playful way of referring to the line y equals x, notice how the red graph flips over the line y equals. In fact, just imagine this is a sheet of paper and you crease the paper on this dotted line. And if this were like red ink and it were like still wet, and if you folded the paper on this crease, that ink would leave a mark right here on the inverse function. So label one of them as f, label the other one not as y to the negative 1, too confusing. Instead, label it as f inverse. Okay, and then here's another one they want us to try. Remember, this is one that Jay asked about. He said, wait, why is it 1/2 x plus 2? Well, because we divided 2x by 2, we divided the other one by 2. So let's do this one in red, and then the inverse in blue. So sketch the graph of y equals 2x minus 4. Make sure you go up 2 over 1 for the slope. We're going for beauty here. This is graph of f. Do me a favor, sketch the Dan-Eddy line very precisely. Be very precise about the line y equals x. And then the blue line, which has a slope of 1/2. Perfect. Perfect. Look at the symmetry. The line y equals 2 plus 1/2 x, which we discovered on the previous page, is the inverse function, f inverse, of the original red function. We see the perfect symmetry. When you combine red and blue, they're symmetric with respect not to the x-axis. They're not being flipped over the y-axis or reflected over the axis. They're being reflected over the line y equals x. Any follow-up questions on this one? The beauty of symmetry is part of what we expect you to learn today. It's what page 2 of this lesson is about. Let's go to page 3. All right. So on page 3, we're going to keep going with this beauty aspect of it. Let's sketch the graph of y equals 3 to the x. Don't forget, this is like a model of a population where a is 1 and b is equal to 3. So the population starts out at 1 million people. And let's, for the sake of beauty, let's put in the population at time 1. Golf ball 1 goes up to a height of 3. And I'd like you to draw not only the exponential growth graph, explosive as it is, but also the asymptotes, y equals 0. So when we reflect the graph of this function over the Dan-Eddy line, Dan? Who's Dan? Who's Eddy? No, it's just Dan Aykroyd and Eddie Murphy. Okay, so Dan Aykroyd is from Saturday Night Live fame. He was on Saturday Night Live back in the 70s. I don't know. It's probably not the best show to watch. I always feel kind of slimed. I think I've been slimed after I watch it. So, you don't have to go. It's not like watching episodes of Saturday Night Live. Even back in the 70s, it was disgusting. But anyway, let's reflect this. So, I mean, there's no doubt the guys were funny. But 0, 1 is like think of that as 0, 1, think of that as Dan, Eddie. When you flip it, you have to go Eddie, Dan. So instead of 0, 1, it's 1, 0. Now, where will the point 1, 3 reflect? If you want to find the inverse of 1, 3, what would the coordinates of the point 1, 3 be once you reflect it over the Dan, Eddie line? So what do you think, Jack?
1, 3.
No, when you reflect it, they have to trade places.
Oh, 3, 1.
Dan Aykroyd and Eddie Murphy starred in the movie Trading Places. Have you seen that movie? It's probably not worth watching. But the two men did trade places in life. So, but you said 3, 1, didn't you?
Yes.
Yeah, that's how you do it. You go to 3. If you want to see the beauty, 1, 3 reflects to the point 3, 1 when you reflect it over the Dan Eddie line. Now, but there's more to it. Not only do you have this curve, it's actually a log curve, but the asymptote itself has to reflect. So you're not done until you put a dotted asymptote on the y-axis labeled x equals 0. Once again, we see the beauty of symmetry when you reflect the graph. And please write the equation, y equals 3 to the x. The inverse of an exponential function is a log function. This is going to be y equals log base 3 of x. And check that out, Sophia. 3 is the base of both of them. And that's how you can tell that you're doing it right. Base of the exponential expression is 3. The base of the log expression is 3. So let's go on. There's just a few more examples here. Just practicing with the algebra. And let's work them hard to easy. So let's do the last one first. Let's make sure we get number 3. They've already replaced f of x with y. So try this one on your own. Replace y with x and x with y. See what happens when you try to solve this equation for y. Try it. Go and try it. Try number 3. Let x and y trade places and then solve for y. I'm just going to tour the room and see what we come up with. Some of you remember the arrow thing from yesterday? The arrow thing is actually the key to this third one. That's why I want to skip down to this one, because the others we've done before. If you use the arrow thing, you know that the exponential form, this by the way is x and y trade places for the code. This is S1. And the arrow thing is coded as EF. That's how you get to exponential form. We have LF, which is log form. But when you have a log equation to solve for y, you have to put it in exponential form using the arrow thing. That is 2 to the x minus 1 equals y minus 2. Any questions on how to use the arrow thing to get the exponential form? Trivially, we just have to add 2 to get the final answer. So we get y equals 2 to the x minus 1 plus 2. It'll be a 2 to the x graph. Write 1 up 2. You already know how to sketch these graphs. You look at that, it speaks. Write 1 up 2. If you want F inverse notation, you would say F inverse of x is 2 to the x minus 1 plus 2. Try another one. Try number 2 on your own. We're working from the harder ones back to the easier ones. This is just arrow thing. Use the arrow thing to do number 2. Oops, I should have had you let x and y trade places first. I was a little premature on the arrow thing. First write x equals log base 4 of y, and then use the arrow thing. Hopefully you have 4 to the y, rather 4 to the x equals y. That's actually a good place to stop. The other example is online if you want to see that online. That's one to review. But the arrow thing gives us 4 to the x equals y That's the answer to number 2. Hey, the homework is due on block day. It'll be solutions will be posted by 4 p.m. tomorrow, but hopefully at 4 p.m. today. Have a good night.